I'm Corey Rosenbush, President and CEO of the Fertilizer Institute. Welcome to the InfoAg Learning Exchange webinar series, and we thank you for joining us today. As we seek to advance modern agriculture through data-driven solutions, the InfoAg content lineup has expanded to include a wider reach of tools, technologies, products, and practices that you can use to help serve your customers. This includes a broader perspective of solutions to support the 4R nutrient stewardship framework, using the right source of nutrients at the right rate, at the right time, and in the right place. As the industry advances with new technologies and practices, the Fertilizer Institute is proud to be a resource for you. If you like what you hear today, please consider joining us for a virtual InfoAg conference on December 15th through the 17th. A full schedule and registration is now available at infoag.org. Before we get started with today's presentation, I'd like to thank today's Learning Exchange premier sponsor, EFC Systems, along with all of our series sponsors. InfoAg would not be possible without their generous support.
Thank you, Corey, and thanks again to our sponsors, EFC Systems. Today's session features a presentation from Eric Snodgrass, the Principal Atmospheric Scientist, Nutrient Ag Solutions. Following some Q&A with Eric, EFC Systems will share some insights into their product lineup. But first, we have a couple of housekeeping items for you all to be aware of. For the CCAs today on the call, the QR code for this course will be displayed on the screen at the end of the session. To get your credits, open the CCA app on your phone and point your camera at the screen. If you have any trouble with this, please let Sally Friss with the Fertilizer Institute know. Her email is sflis@tfi.org. On the right side of the screen, you will see a chat box, which you can use to talk to other attendees. Above the chat box, you'll find a series of tabs which you can switch through. Please use the Q&A tab to ask our speaker any questions. We will publish your questions as they come in, and you can vote for the questions you'd like me to ask to Eric. All right, and we have Eric on today. Eric, thank you for joining us today. I know you've been working in ag meteorology and crop sciences for many years. Can you tell us a bit more about yourself?
Yeah, sure. So I am the Principal Atmospheric Scientist at Nutrient Ag Solutions, and that basically means that every day I serve as part of the decision support for our team here and also for grower customers and farmers around the world, just trying to understand how weather is going to impact business. And that's what I do. I study the relationship between weather and operations, weather and yields and production, and try to figure out how we can kind of expand the limits on what we know and understand about forecasting future weather events. So I got my head in the clouds every day and my fingers on the computer here, just developing software, writing code, doing some fun stuff to try to understand how weather affects our business.
Fantastic. So today in your presentation is titled, What's New in Meteorology? Go through why is this important for you and for the CCAs? Why is it important for us to really be up to date with this?
Well, weather and the science behind weather and weather prediction is evolving quickly. And we all know that weather risk in production ag is kind of at the forefront of what can take a great year to a horrible year or the opposite way around. And so what I want to do in this video is I kind of want to show you what we know, what we do, how we do it, explain a little bit about our forecasting techniques, the new technologies in place there. But at the same time, I want to walk you through the 2020 growing season. I want to give you a near-term and a long-term forecast and talk a little bit about some international weather. So I've got a lot kind of packed into my time today. We're going to move through it. So I hope there's a lot of questions that come through this.
Thank you so much, Eric. With that, we appreciate it. And everybody, let's enjoy this presentation.
Hello, I'm Eric Snodgrass, Principal Atmospheric Scientist at Nutrient Ag Solutions, and I want to thank you for giving me some time today to talk to you about how weather has impacted the 2020 growing season. We want to talk about the new technologies that are available to help us watch and observe these weather systems and then forecast them. We want to talk about new research that's coming out that helps us to understand how weather is impacting yields and production, not only here in the U.S., but also globally. And finally, we want to use all that technology to make a forecast. And that's what we're going to do at the very end. Stretch this out to look out through through winter and spring and get a glimpse of what we might be seeing next year, and also talk about what's happening in South America right now. So without much more, let's get right on into this. This is why I study weather and ag. It's to understand variance. So this map I produced here shows you from the year 1980 to 2019 what yield variance looks like county by county across the United States for corn. Now, the bluer counties here represent places where the yield variance is very low. Year on year, they have very steady production. But as you go over toward these colors down here, the bottom of this color spectrum, those would be regions that have higher variance. You see, ultimately, as we study each part of the United States and the crops that we grow there, we need to know every year how weather is going to impact things. And I'm going to share with you what we learned in 2020 and talk to you about the bigger picture things. And we're going to start with hurricanes. This is one of the most incredible videos from this year. October 21st, Hurricane Epsilon. The Hurricane Hunter is about to make an eyewall penetration here at 10,000 feet above sea level. And there you are in the middle of the hurricane. It's amazing. Since 1942, when the first flight ever into the center of a hurricane occurred, which, by the way, was done on a $1 bet by a guy named Joseph B. Duckworth. I made that bet with some pilots he was training that were from Great Britain during World War II. Well, anyway, he successfully flew into a hurricane, and it began the modern era of hurricane reconnaissance. Well, the Hurricane Hunter here, which is the Orion P3, flew into the center, and it's trying to navigate its way to the middle, where it will drop an instrument pack called a dropsonde, from which we will collect vital data which will help us project the future path of this tropical cyclone. Well, 2020 produced a lot of tropical cyclones, and I'm going to show you their impact. So this next map you're looking at here begins on January 1st and goes until the 16th of November. And what it shows you is, by climate district, the rank in terms of total accumulated precipitation. We got 128 years worth of data in this data set. And everywhere that you see the number 1, that would be the wettest such time period on that record. 128 would be the driest. You see, what we want to discuss today was, what was it about 2020 that set up the prolific drought and heat across the Southwest, where there were tremendous fires burning over 4 million acres? What gave us the flash drought right here in the center part of the Corn Belt, from parts of Nebraska through Iowa, southern Wisconsin, and northern Illinois, and at times even over the eastern Corn Belt? And then, what allowed the atmosphere to do this? Produce storm system out of storm system out of the tropics that went racing toward the southeastern part of the United States. 12 of them, in fact, that either brushed along the southeast or made a direct landfall. You see, we went deep into the Greek alphabet, which is our contingency plan when we think about naming hurricanes, because our name list only has 21 names on it. And here's the simple ingredients. So if you're watching this and you are impacted by hurricanes, here is what we have learned about forecasting seasonal hurricane variance. It's 2 factors, and the first one is ocean temperatures. You see, by mid-September, look over here in what's called the main development region. That would be the Central Atlantic. Then getting here over into the Caribbean of the Gulf of Mexico. In that region, we saw all summer and fall long that the ocean temperatures were well above average. I'm drawing a black line showing you what average is, and that blue line tells you that in the MDR, the main development region, how warm things were. Hurricanes feed off of the heat of the ocean, and the warmer it is, the bigger and badder they can become. You see, the second ingredient is related to ocean temperatures, but it's the ocean temperatures over here. All summer long, we saw the development of a La Nina. And what typically happens when there's a La Nina in the Pacific is that the winds over the Atlantic calm down. And if the winds calm down over the Atlantic, hurricanes can spin up in a hurry. We call that wind shear. Now, wind shear is just a change of wind speed and direction with height. And any pilot listening to this talk today knows exactly what I'm talking about. What you have over here on the y-axis is increasing wind shear. And why hurricane season typically goes from June to November is because climatologically, in other words, on average, that is the time of year where we have our lowest wind shear values. Now, the Atlantic is warm and calm, which means a tropical system could easily spin up and become violent. And if you notice in blue, which is the 2020 values, we went from higher than normal wind shear values at the end of August and dropped way down here by the time we got to the end of September. And as a result of that, look at what happened mid-September. At one point on the 14th of September, we had Sally, Paulette, Renee, and Teddy all out there spinning. You see, the environment was warm and it was still, and it allowed for these tropical cyclones to develop and develop rapidly. Now, many of these tropical cyclones that made landfall did so and produced a lot of flooding. But one of them, Hurricane Laura, was the strongest so far this year to make landfall in the United States. And with our new Doppler radar technology here, I'm looking at an image produced by RadarScope, a great app, shows you how intense that system was as it made landfall in Louisiana. This was the last radar image we had early in the morning here as Laura made landfall. And using our Doppler technology, we were able to not only show you images like this, which give you the intensity of the precipitation, but also images like this, which tell you the wind speed and direction. You see, this is what the Doppler in Doppler radar gives you. And we were measuring at 1,000 feet above the ground wind speeds that were 169 miles an hour toward the radar. Now, when we come down toward the radar's height, those wind gusts were topping 130 miles an hour. And when it hit the Lake Charles radar, it actually completely destroyed the radome. That's this large, almost looks like a soccer ball protective covering that goes over the dish, which is normally sitting on this pedestal, which was completely ripped off of the pedestal and destroyed here. You see, some of these tropical cyclones not only produced incredibly strong winds, but also a lot of flooding. Now, Tropical Storm Eta was the most recent tropical storm to make landfall in the United States, and actually did it twice. It hit southern Florida first, then curled out and then came back over and hit northern Florida second. As it went across southern Florida, look at the rain bands on the northern side of this, just producing a deluge of rainfall. Now, something to think about whenever we get this much rain, because you saw in the southeast a lot of rainfall, is just remember something: turn around, don't drown. Now, I think this guy over here that you're about to see coming on the left-hand side of this image didn't get the memo, because here he is driving his Lamborghini inside of floodwaters. There's a lesson to be learned here if you own one of these cars. They're shaped like a wedge, which means the faster you drive in deeper water, that means the car is going to attempt to dive into the water. And I kind of wonder if he felt like he was reenacting a little bit of James Bond in his Lotus in The Spy Who Loved Me. Now, I know this is kind of weird, but Roger Moore is my favorite James Bond. It's probably because I grew up in the 1980s and he was the Bond of the 80s. Plus, those were all the James Bond movies with Jaws. Well, anyways, here, I don't think that this guy was prepared for diving under the water like James Bond was. But it just reminds you, turn around, don't drown, especially in your $200,000 sports car. All right, our most recent and most powerful tropical cyclone is Iota. And this was yesterday, as Iota made landfall here in Nicaragua. It rapidly intensified to become the first Cat 5 hurricane of 2020. We had several others that got close, but this was the most powerful. And as it went slamming in here into the Nicaraguan coast, it did a tremendous amount of damage, both with wind and incredibly heavy rainfall. Now, since we're thinking here about hurricanes, I would like to give you some statistics. You see, as time goes on, we're able to collect more and more information, and the research I'm presenting to you comes from Dr. Ryan Maui. And what you're looking at here is globally, so this isn't just the Atlantic, but the whole globe. What we've learned is that when hurricanes form, with time, since the 1980s, they've been becoming bigger, have more rainfall, spin faster, and are larger in size and energy content. But it turns out that globally, the hurricane frequency is almost flat, if not declining. But our major hurricanes, as denoted down here by this trend line, are increasing. So that's critical for those of you watching that are right there along the, along the Gulf Coast and farming. Tropical cyclones are really increasing the frequency of problems throughout our growing season. Now, before I come back to the U.S., and since we're talking about flooding, I want to take you to a couple of international things that happened this year. First, we're going to look at China. The image that's in the center there, that's animated for you, that video, that is the Three Gorges Dam. From June 1st to August 1st, on that dam, we had surrounding it in the floodplain 45 to 60 inches of rainfall as a frontal boundary stalled out and hammered this area. You see, this year in China, including a reduction in acreage, plus flooding along the Yangtze River, and 2 typhoons that hit the Manchurian Plain, they had a tough year in growing some of their big crops, like corn and soybeans. And this is just one of the things that's really been pressuring global supply of crop as we get here to the end of our 2020 growing season. Here's another thing. Throughout this summer, we saw desert locusts coming out of parts of the Horn of Africa, Somalia, Ethiopia. They spread across the Sahel, which is right there in the center part of Africa. They went to the Arabian Peninsula, Iran, Afghanistan, Pakistan, and India. And this is, in my entire tenure of studying weather, the worst locust outbreak that I have ever witnessed. While it created food security issues in this area, it wasn't enough to really knock on the door of causing problems with some of our big staple crops that we grow around the world. But I will talk to you about one other area that was seeing some problems late in the season, and it was over here in parts of Europe. While much of Europe had a very, very wet end of summer and beginning of October, when you come over to the eastern side of Ukraine here in the southern Russian wheat belt, there was major drought that settled into this area. And at the end of this video, I'm going to explain to you what helped push a lot of these events along. But before we get there, I would like to just come back to what took place late this summer that gave us this map. So now instead of looking at the entire year, this is August 1st to October 1st. In other words, late summer into early fall. We're looking at those precipitation ranks maps once again. You see, what developed this summer in the jet stream was critical to understanding why we saw flash drought. It was critical to understanding why we saw prolific wildfires. And this was some yield-robbing jet stream flow pattern, but also at the same time one that produced some extremely severe weather. Now, because we're so limited on time today, I'm only going to get to talk about a couple of different severe weather events. But if you look over here at the map on the right, this was our flow pattern in the jet stream for the end of summer. Now, what is it? This feature right here, which I'm putting a circle around and an H in the middle, is a large ridge. It's where the jet stream winds were diverted to the north around a large dome of heat that set up across the western part of the United States. It's what sent this region over into extremely hot and extremely dry conditions. And this is what it looked like. You see, watching the flow of the atmosphere, you can see that ridge right here. And the flow comes around it just like this, and the jet stream was very weak to the north and running up over the top of it just like that. Now, what you end up getting out of this is what you see over here in this animation on the western side of the United States. Let me pause that right there and just take you back so you can see the sunset again. You see, as the sun was setting in this animation here at the end of August, yep, there was a big tropical system here in the Gulf, but you can see how much smoke was in this ring of fire configuration in the western part of the United States. And that's because many of these thunderstorms were high-based dry storms producing a lot of lightning. And as they produced that lightning, things started to burn. What you're seeing here are a couple of images showing these large fiery vortexes spreading the smoke and the fires very quickly across the west. Here in California, this is what some of the ash looked like from some of the fires we saw there near Santa Rosa. And here was an incredible video from San Francisco where the thick smoke covered the city, allowing only some of the red light from the sun to get through. In fact, at this particular point, no direct sunlight was being measured at the surface. It was all indirect and very long wavelength light, which is what happens when the smoke is so prolific. Now, on September the 6th, this was probably one of the worst days for the western United States in terms of wildfires, because the winds were about to change direction as we went into the Labor Day weekend and get quite fierce. You can see the smoke over California, Nevada, and parts of Oregon and Idaho, but I want to take you to this fire right here. This one is called the Cameron Peak Fire, and it looks something like this when they flew by it with an airplane. Now, I live in Champaign, Illinois, which is in eastern Illinois, and we actually saw the smoke from this fire spreading across Kansas. It spread across Missouri, went over the top of St. Louis. We could see it way up high in the atmosphere over my hometown of Champaign, Illinois. Incredible, to say the least. But that same pattern set us up for drought and a derecho in the middle part of the country. Remember? You see, as the flow came around in that ring of fire configuration, we were dealing with some problems in the Midwest. And I want to explain to you what some of the longer-term trends look like throughout the Midwest by looking at the primary corn and soybean belt precipitation trends. Now, when we look at some of the data from NOAA going back to 1948 to 2020, what I'm showing you here is that between the months of April to October, across the primary corn and soybean belt, we have seen an increase on a linear trend here of 5.5 inches of rainfall during our growing season. This is part of the reason why our yield trend is so positive, to the tune of about 2 bushel per acre per year across the Corn Belt. But there are still time periods where precipitation variability robs us of yield. Let me explain. I did some research across the state of Illinois and Iowa lately, and I went back to 1981 and looked at 2019 at the frequency of 2-inch rainfall events per day. And what I found is that for the state of Illinois, we have doubled the frequency of 2-inch rainfall events, and in Iowa, we've tripled them. Now, what do you do with this research? How do you put it into context? What this means is that we are seeing an increase in total precipitation, and at the same time seeing an increase in precipitation variability. That is translated into the fact that we're getting more of our rainfall in big helpings followed by flash drought. This particular scenario has robbed us in spring, which I'm calling April 15th to June 1st, of 5 planting days. It's also increased the time periods throughout summer where we have longer stretches of hotter and drier weather. And let me show you how that happened. Now, I don't have time to cover the whole country, so we're only going to watch from Nebraska through Iowa all the way here over to Ohio, right in this area. This is the top 4-inch soil moisture values, and it's every day from mid-July. As we get this animation playing, the first thing that shows up here is that throughout the month of July, there were pockets in Iowa that showed up extremely dry. Same thing for southern Michigan, Indiana, and Ohio. And as we play this through the month of July and into August, those drought areas grew rapidly. Here's the 15th of August, now working our way up to the 21st of August. Look at that. Very, very dry conditions across here. But it was punctuated with big rainfall events as well. For example, as I go to the end of August and now the beginning of September, watch what happens on September 7th, 8th, 9th, and 10th. One big system came through and wiped that out. You see, these are the variations that we're noticing are happening more frequently. And the worst of these came in the form of a derecho on August the 10th. Here it is coming out of South Dakota and Nebraska, sweeping across Iowa, cutting into Illinois, Indiana, and southern Michigan. That one storm system, as it went across this area, traversed over 700 miles at an average speed of 55 miles an hour and produced 500 reports of severe weather. You've seen the videos. You've seen the pictures. Cedar Rapids, one of the hardest hit places by this derecho, just an incredible amount of wind, sometimes gusting over 130 miles an hour. It destroyed corn, it destroyed infrastructure, and it laid beans flat. And based off some satellite estimations, we put the number of damaged acres at 8.5 million. The last time something like this happened was in 2011. What an incredible event middle of this season. Toward the end of the season, the drier conditions that we got, the flash drought at the end of the season, produced widespread fires in the Midwest. Chad Colby caught this picture from his Cessna here. You can see a burn scar across central Illinois. Or in Minnesota, this field had a fire run through it, burning off the stalks and the leaves, but leaving here the corn still hanging to be harvested. What an incredible year. Well, as we think about what got us going here, I want to give you some big picture things, and we're going to talk about El Nino and La Nina as we work our way toward the end of my presentation. El Ninos are characterized by warm water that spreads off of South America. They're a disruption in the flow of the trade winds, and they shift precipitation across 7,000 miles of open ocean. We love El Ninos in the Corn Belt. We love them in California. They bring in additional rainfall in winter for California and regular rainfall across the summer in the Midwest. This year, we didn't have an El Nino. We had a La Nina, the opposite. Cool water, strong trade winds, and as a result, more chances for drought. Now, when we think about this, we've had these events going back to, 1950 since we've been observing them here, and we know what they look like. There's been big El Ninos like the one we had in 82-83 or the 97-98 or the 2015-2016 and the big La Ninas like the most recent in 2010-2011. Well, right now, we're right down here with our current La Nina, and that's going to dominate our pattern through the remainder of this year. It took a long time to develop this summer. From June 1st to November 14th, this is what ocean temperatures look like, and you can see the La Nina developing right here with the cooler waters. Well, given that, what does it mean in terms of our weather patterns? Well, here is the Meteorology 101 of the differences between an El Nino and a La Nina. It looks something like this. One of La Nina's biggest impacts is it tends to steal at time the westward momentum in the atmosphere. Makes the jet stream a bit slower and more north-south oriented. El Ninos tend to be fast, more zonal. They tend to stretch from west to east quickly, and they have a strong subtropical component. Now, given that as the setup, the atmosphere tends to become blocked more often. And with more and more data, we're discovering how these factors influence the flow of the atmosphere. You see, with those blocking patterns, we tend to get bigger shifts, like we saw here at October. A lot of very cold air at times in October coming out of the Canadian prairies, one of our coldest Octobers on record, followed by one of the hottest starts to November. That's what you tend to get when you have a La Nina. You go from one extreme to the other. Look at this quarter in through here for the beginning of November. November 1 to November 11th, several locations here are having their warmest start in history to November. Pretty incredible to see that. Well, here's the other thing that we find that La Niñas tend to do. They mess with the jet stream. And throughout much of October and November, it tended to take the jet stream much farther north and allow it to dive across the United States just like that. It tends to weaken the subtropical branch of the jet stream. And that's what I want you to take home with you today when you start to think about the impacts of this longer term. Because right now across the western United States, we have widespread drought. Here's your latest drought monitor released last Thursday. They're released every Thursday, okay? So this is the one on November the 12th. And what we're concerned about here is what this drought picture is going to look like once we finish this winter. Now, how do we do our forecasting? Well, when we think about predicting the future weather, we rely heavily on weather models. And through the next 10 days, our weather models from the European Center and from the US, well, they are the best in the world, and they're not going to be able to have humans outperform them. All right, that's just the name of the game. I'll show you how accurate they are and why the European's the best. This is a graphic that shows you skill going back to August. And the blue line there is the European. And you consistently see that it is better at forecasting than the GFS. But the GFS is a close second. That's a US model, by the way. And at times the GFS outperforms the ECMWF. But what's smart to do is blend the models and use them together. Now, what I want to tell you is this. The most toughest time period to forecast is day 15 to day 45. We call it no man's land. Here you're looking at a forecast skill versus lead time, and you can see that it's during that time period that everybody wants a day-by-day forecast, and that is impossible to deliver. I'm telling you, it's impossible to deliver. We also have other sources of getting weather information, like the Farmer's Almanac. To be honest with you, I have no idea who produces this, but this is their forecast for this year. It's just another piece of information, just something I want you to see. But I'll be honest, the Farmer's Almanac doesn't have that great of a history at being accurate. So what can we expect for this winter, and what about South America? Well, over the last 45 days, the jet stream has done this. Look over here at the map on the left. It's come across Japan fast, went up here into British Columbia, and then dove over the Great Lakes. There's been a ridge here. We can see it by looking at this anomaly figure. Do you see the circulation right in through here? That's what shoved the jet stream north and allowed it to dive out of the Canadian prairies, bringing in some colder air at times in the month of October. Now, as a consequence of that, over the last 45 days, this has been our source of cold air. It's piled up snow here on this side of the Rocky Mountains, but continued to keep several areas dry from California to Texas into parts of the Corn Belt. We've continued, though, to put hurricanes into the southeast, which has kept them quite wet. Well, over the next 10 days, we have days 0 through 4, which gets us to Friday, as being very dry across the midsection of the country. So if you've got field work to get done, get out and do it. Because by the time we get to day 4 through 10, which gets us all the way out to Thanksgiving, we see that this quarter in through here is going to have a high pressure center to its south and a stationary boundary parked right in through here, on which we're expecting to see quite a bit of precipitation. All right? So prepare for that. Now I'm going over this quickly because I want to get to the longer term. Week 2, another trough digs out of the west, but the flow is relatively flat across this part of the country. So what do we get? Wet conditions here. And as the front I just showed you moves east, it's going to get wet over the eastern part of the United States compared to normal. But no major precipitation deviations from normal into week 2 as you look across much of the eastern 2/3 of the United States. Well, what about temperatures? Well, that pattern's relatively relaxed. Here's the next 5 days. Here's days 5 through 10. And here's days 10 through 15. We're going into a mild end of November and start to December. Keep that in mind. Now, what about beyond that time period? The next 30 days, as forecast by the extended GFS and the European, keep the storehouse of colder air here. That is very typical of La Niña and a more relaxed start to early winter. But I'm going to tell you something. This will be punctuated with quick, brief hits of colder weather. That's the normal that we get during this time of year. But this is not indicating an early season drop-off in terms of temperatures. In terms of precipitation, I don't think the GFS has a good handle on this. But look over here at the European. Keeping the northwest wet. Keeping this region over here with probably an active storm track, but drier along the Gulf Coast. And I tell you something, those folks down there couldn't be happier to see that given how wet things have been. Now going beyond this, We're not going to get into all these details, but I just want to tell you I'm a giant nerd, and I have to look at every single one of these things every day to figure out the weather across the United States. These are the teleconnections we have to watch, and I'm just going to talk to you today about two of them, okay? The first one is going to be something called the Arctic Oscillation, or the polar vortex. This particular year, we are seeing the polar vortex become established right here. Let me draw this in a little bit different color, in red. Right over this region. That's the Chukchi Sea and the Bering Sea. In that region, Arctic sea ice this year reached a record minimum. The last time it did this was in 2012. And in 2012, when we did have really cold air outbreaks, they came over a ridge here and slid like this, especially late in the season, and hammered this part of the United States in the Canadian prairies. That's just one analog year, but it's one that I want you to look at. Now, how do we understand the polar vortex and the Arctic Oscillation? Because we think that it's being caused here by the heat flux that's coming out of the Arctic. Well, here's what I want you to remember. When the polar vortex is strong, it keeps a big tight grip on all the colder air. How do we watch this? Well, look over here with me on the right. I'm drawing a line here indicating throughout the winter season, the strongest the polar vortex has ever been. And here is the weakest. It's currently sitting right here. And average would be there. Now, what do you need to know? The stronger the polar vortex, the greater its grip on the cold air. If we start talking in the month of December, January, February, about a disturbance in the polar vortex that sends its values down, then the cold air is going to get unleashed somewhere. Right now, it's just all sitting right here. And it's not really too disrupted. It's starting to show some elongation toward the end of November, but this is still a strong polar vortex. Let me explain this one more time before we get on to the end of this. You see, when the polar vortex is nice and tight and sitting on the northern hemisphere, all the cold air sits over the North Pole right there. But if it's weakened, like it was in January of 2019, and it's split, like one piece goes here and one piece goes there, what you end up getting are these massive colder outbreaks. This one, which happened at the end of January 2019, this young lady soaked a pair of her stretchy pants in water, tossed them up in minus 30-degree air here in Minneapolis, Minnesota. They froze in midair and perfectly stuck the landing in the snow. One of my favorite videos. So we have to be watching this. But ultimately controlling the background state of the atmosphere is this La Nina. And as we work our way toward the end here, I want to tell you what that La Nina is going to do. You see, it's down here, it's strong, its ocean temperatures in the Central Pacific are at -1 to -1.5 degrees. It's going to stay there throughout much of winter. This is the December, January, February forecast. It'll likely reach a peak around January and start to fade after that as we work our way towards spring. That will be critical for the upcoming spring forecast. So what do we expect? We expect the jet stream to do this. Follow the arrow I'm drawing. If it does that, that gives us more systems that come out of the north cutting across the prairie. We get a lot of Alberta clippers. I went back and looked at every year since 1990 and identified these years right here as looking most like the 2020 La Nina. What did those years give us? They gave us this. They gave us a lot of cold air in here that was at times let out across the Canadian prairie into the northern interior of the United States. The jet stream tended to do this, which gave us a lot of Alberta clippers and also several Colorado lows and what we call panhandle hookers that come out of the panhandles of Oklahoma and Texas. So thinking about that, here's what NOAA's forecast is for 2020. You see, they've split the country north versus south here on the temperature pattern, and also keeping it wet here in the Ohio River Valley, but drier along the southern tier of the U.S. That's why I'm very concerned about the continuation of drought here. Let's finish this up by looking here a bit at some of our models. The European is bought into this for December, January, February as well. The cold source of air will be here and at times really run into the northern tier of the U.S., but it will likely be warm across the south. It'll also be dry in that area with wetter conditions in the Pacific Northwest and in the Ohio River Valley and through the Great Lakes states. That's the European. Do the models run in the United States agree? You better believe it. Here is the National Multi-Model Ensemble. See it again, the wetter conditions here and in through here with dry, no subtropical jet stream really showing up here from California across the south, keeping it warm down there with the cold air at times coming out in this direction. And finally, here's the IRI multi-model analysis. They once again have the wetter conditions here, here, and here with dry across the south. The cold air is sourced there and at times comes into the central plains of the U.S. Now remember, this is a 3-month forecast. You'll have variability week on week, but this is what we expect things to look like when it's the end of February and we just average the 3 previous months. So remember, we're in the United States. Winter's volatile no matter what. This is just the general pattern if El Nino controls things. If La Nina controls things. What I'm going to be watching, though, is how this influences South America. You see, Brazil's production curve is exponential because every year they have averaged planting an additional 1.6 million new acres of soybeans. Just remember a number here. Brazil currently only farms 8% of its arable land, and the target this year would be a trend value of 132 million metric ton. Just so that you understand the size of the Brazilian growing area, we have put Texas here inside of the state of Mato Grosso, which is their biggest producing state. Now, thinking about Brazil, they had a rough start to the season. Through mid-October, they had built up over a 6-inch deficit and a late start to the monsoon, and it was very dry in southern Brazil. And that's what got them started off planting late. But they made up a lot of progress over the last couple of weeks, and you can see that right here where they jumped back toward their normal progress values. But this means, like we did in 2018 and how Iowa did this year, that much of the crop was planted inside of a 15-day window, which is going to make forecasting in January critical during pod fill and when the pods here are going to be maturing. So from there, over the next 2 weeks, we have pockets of dryness in this section of Brazil and also in Argentina. And as we get out into week 2, look, drier conditions coming in here as La Nina is having its influence here on the flow pattern across Brazil. Now, there's several of the components, but just in the interest of time, that is certainly being affected right now by La Nina. What I'll be watching is down here in Argentina, because it's been very dry in Argentina, but they may get a brief interlude of some wetter weather into week 2 during our Thanksgiving week here in the United States. But longer term, and this is my last slide, we expect for December, January, and February to see drought issues here and here. And that's what I want to be watching very carefully. So that's how we do it. This is how forecasting is done with our models, plus our analog techniques with some human influence. And I hope you found this instructive and useful, and I look forward to all your questions. Have a great rest of your day, and thanks for watching.
Man, Eric, fantastic presentation. Wow.
Thank you.
Really, really fascinating. I enjoyed it a lot, and I'm sure we've already got a lot of questions. I'm going to re-ask some that you've already answered in chat, and we're going to start going through. Everybody make sure that if you have a question for Eric, please enter them into the Q&A tab, and we'll start moving through. So let's get started with the first question, which was, how are the soil moisture measurements taking for that soil moisture video you showed?
Yeah, so that's actually a NASA product, and it's a pretty good one. I actually talked with the folks that produced that and also the people that make the U.S. Drought Monitor out of the University of Nebraska at Lincoln. And so matching that data from satellite up with actual ground truth has been done, and it's a very, very solid product. So I put the link to that in the question and answer. So if anybody ever wants to access that data, it's there for you.
Fantastic. Thank you. Next up, and like I said, you got to this one, but expand on your answer. So is what do the probabilities mean for La Nina? I thought they were supposed to be cooler and wetter than normal in the northwest Minnesota, and yet we've been warmer and drier.
That's right. So what La Nina tends to do here is it tends to kind of block up the jet stream a bit, and it tends to get it stuck in certain configurations. In other words, La Ninas tend to rob the jet stream of a lot of momentum. Now, historically, that's correlated to a cooler northern tier of the United States and the Canadian prairie. And I can give you the number. The correlation coefficient is 0.39. So if you want to know how strong that correlation is, it's not like it's a 0.9, but it just tends to favor cooler weather across the northern tier of the United States, which is why NOAA, and this is why the major modeling centers all have got that cool. But in the falls, during a La Nina, we often just say it's a blah weather pattern where it just tends to do like it's going to be doing here over the next couple of weeks, which is favoring more above average temperatures and a less volatile pattern until we get established into winter, which is what I think is going to be the case this year as well.
Fantastic. So Billy's got a question, and I think everybody's on pins and needles to know it's which one is the best weather forecast provider so that I can take into account to plan my season.
You know, getting weather forecasts is tricky business, and it kind of comes to a slide I showed in the middle of the talk, which basically said that as you get out beyond 5 to 7 days, the probability probability of the forecast being accurate, in other words, telling you on your field exactly how much precipitation you're going to get or the temperatures, it just drops off. That's just the nature of the beast when it comes to forecasting something that's nonlinear and chaotic, which is the flow of the atmosphere. Personally, I am a big fan of doing a model combination. Like I said in the presentation, the European model is the best. The GFS is second best, and putting them both together tends to give us a better solution of what's going on. But in the United States, we have a weather service that is second to none, and some of the products that are put out by the National Weather Service are very good. So you ask where to go to get that stuff. Well, let me give you a few free resources, but also put something else in the back of your mind here. One of the great things that Nutrien is allowing me to do is to actually build my own weather app and API. I've got a great team behind me working on this. So I plan in the next year to release what I hope to be the premier ag weather resource. In the meantime, here's a few sites to check out. Pivotalweather.com. Pivotalweather.com. Go Google it or put it in your browser and check it out. You can get access to all the weather data there. Tropical Tidbits is another great one that I enjoy, and always go to weather.gov. But if you want a good app on your phone where you can just, use the phone to access data, understand that I think that the one that NOAA puts out is probably the best. I do like Weather Underground. My favorite radar app is called Radar Scope. And My Radar is also another really good app. So, but I'll tell you this, some of the commercially provided apps play some tricks on you. And what I mean by that is we've found that they artificially inflate the precipitation probabilities, because it turns out if they do that, people check the app more often. So be careful which app you use. But I promise you, the one that we're developing, Nutrien, will not do that.
Well, you named off all the apps on my phone, so I feel better about myself that I wasn't missing anything yet. And so we've got a question that jumped up. It was posed by Laura Moody, but we got a couple more. So should crop advisors be implementing long-term weather predictions into timing and production considerations, specifically for nutrient applications?
Wow, that's a fantastic question. My answer is two-part. And the first part is no. And the reason why I want you to do that is because I need you to understand that long-range weather forecasting is not an exact science. Now, understanding that, we can use the long-range weather information to find out what are our chances of being one way or the other. So, for example, think about this past June. It was extremely windy in June and made it very difficult for a lot of folks in the midsection of the country to do their normal June applications. We had ideas about that in May that we hey, the probability of this is high. But at that point, not a soul on the face of the earth could have told you, oh, you know what, on June 15th, that's going to open up and you'll have a good shot. The reality of it is forecasting that much beyond just a few days is nearly impossible. So we ask to live with a 15-day window on their forecast, but look at the longer-term things as a broader planning strategy. We think about that with respect to precipitation, wind, and temperature. That's an excellent question. I could probably give a whole other 2-hour seminar on just trying to get that one answered.
All right, we've got about 2 more minutes, and I remind people to vote on a question that's up there, but I'm pretty sure this is my buddy Mike Manning. He's asking, what does a CPC use to make their long-term projections?
Question, their own model, and the model that they use is called the CFS V2, Climate Forecasting System version 2 model. They combine that model output with an analog technique, and an analog is basically where we write some software that goes back and historically correlates current with past weather. They combine things together and give you the long-term about stuff that's beyond their 15-day outlooks. So it's a 2-part system, a dynamical model and an analog model with which they use to create that forecast. Excellent question.
Okay, we have time for one more question. I want to do Angie. So the European model has been better for many years. What is the U.S. doing? Oh, it moved. The U.S. is doing to better forecast our own weather.
Oh, a great question. So the United States is making some major upgrades into 2 parts of their system. The first major upgrade is actually happening with the computing itself, making it more powerful, making it faster. That's very good news. The second thing is we're adopting some new technologies like real-time data assimilation, and also going to what we call 4D variable, 4D VAR, which is what the Europeans do. Those new incorporations plus more ensemble members in their forecast is improving our models dramatically. And we're a close second, just to keep you informed there.
Fantastic. I want to do one quick last one since I had 2 votes. Is it possible to get a similar outbreak of locust in the U.S.?
Well, there have been locust outbreaks across the northern plains of the United States going back toward Montana. In fact, they had one this year, a big grasshopper outbreak. I don't think that we could have one quite the magnitude that we saw here in Africa, the Arabian Peninsula, and parts of like Afghanistan over to India, simply because of the way we manage pests in the United States. But we do have locust and grasshopper problems in the northern tier of the U.S. and the Canadian prairie some years, but nothing to the magnitude of what you saw.
All right, thank you. Well, with that, we're at time. Eric, thank you for answering the questions. Thank you for your presentation. I've been absolutely fascinated and enjoyed. But now we've got some more information. We're going to have to move it over to our sponsor. So we've got some information from our sponsor, EFC Systems. So at this point in time, I want to turn it over to Jeremy Wilson.
Hello, I'm Jeremy Wilson with EFC Systems, and we're happy to have sponsored the entire series of webinars through this fall and summer. We've had a lot of great speakers. It's provided some great content for all of us to listen to throughout the summer and fall. So if we think back, when my first presentation, I asked the question about what are growers looking for? What's the goals? What are they after? What are we trying to achieve? Increased productivity, obviously, reduced expenses, reduce risk, increase competitiveness. But at the end of the day, the ultimate goal of a grower like myself is to improve profitability. How can I make more money? I ask you then, what would your role, what do you want your business to play? What role do you want to play in this? Where do you fit? What's important? I'm going to challenge you to be that provider that helps the grower meet his goals, either helping him manage his expenses, maybe helping him market his grain more effectively, or even ultimately help him improve his profitability. I believe EFC offers a complete suite of software tools that allow you to help the grower, more like an agronomic operations platform that can help you work with that grower to meet his ultimate goals. So where are we at today? Harvest is ongoing, probably complete in a lot of areas. I know in my part of the world, a lot of it's wrapping up. There's a field here, there, left, around. We got sampling ongoing. Sampling's running hard right now. And in our part of the U.S. and the Corn Belt, it's still dry early, and throughout most of the fall, a lot of that sampling was held off till we got some more moisture, which has now led to a little later, applying fertilizer. So we got a lot of fertility going on. And prepay season's right around the corner. Ready or not, here we come. Harvest data collection. Let me ask you the question. Did your growers collect yield data? But more importantly, was that monitor calibrated? You can all laugh and say, why are you talking about harvest data collection? Because I think it's an important piece of how you work with your grower to improve his profitability. At the end of the day, we get one chance every 40, you get 40 chances once a year to get a scorecard to understand. Now that harvest is complete, we kind of got to use what we got. But what plans can be made now to improve that yield data quality for next year? But more importantly, who in your organization is going to own the process of improving that data quality? And the last question I'll have you ask, or you need to be asking, is, do we have any needed data we can possibly post-calibrate this yield data so we can make something out of it? In a lot of cases, there probably is. At the same time, how can we make a yield map more than just a 5-color map that we can look at and talk about? How can we use that for fertility recommendations? How can we use that to verify agronomic changes we made on the farm? So when you throw this yield data map up there, yeah, looks like, Jeremy, you did something really right around the middle, but you did something really wrong around the edges. Yep, partially right. We're going to talk about that, and you're going to see throughout this presentation what all went on in this field that may or may not have caused it to look like that, but how that impacted my overall profitability made a big difference. So let's talk about samplings going on right now. Are you working with your growers to be proactive in following the 4R requirements? I'm going to show you an example where that's really critical, and it really showed up in this particular field. But are you working with the growers to utilize soil testing to create field-by-field recommendations? Once again, you might laugh, but I was just floored the number of growers this spring that I met with and run into throughout the summer. With our new normal, I wasn't on the road like I was. It got me spend even more time, around other growers. And the number of growers that said, well, I just spread this on my corn, or I spread that on my soybeans, or I do this on my wheat, just really knocked me over. But more importantly, are you using software tools to streamline this process, to minimize the amount of time you have to spend to get that sampling done, so you can spend more time in the field working with your growers? Who wants to sit in front of a computer and create all the sampling orders that need to be done and get samplers dispatched or pull the samples yourself? I'll challenge you to utilize software tools, because when we apply those and apply the results from those, we can make some positive decisions to increase profitability and to increase the overall ROI of that particular farm or field. I showed you this map before. I'm going to go through a couple slides on fertility here, but I'll show you this first one. We went out and done some pre-plant nitrogen with nitrogen stabilizer, 2 different nitrogen stabilizers. We went out and done some sidedress and hydrous ammonia both. Clearly, if you look at this, you'll see that the sidedress anhydrous was in the middle of the field, the big blue band in the middle. And you know what? We look really smart that we made that decision. Was it all the sidedress nitrogen? I don't know. Within a week of this corn being planted, we had about 8.5 inches of rain. Yeah, some of it got replanted. Some of it was in the sidedress area. Some of it was not. But the fact remains, in this one example, that piece of equipment going through the field to apply that nitrogen, either the nitrogen or maybe the opening up and fluffing up that soil, brought a pretty substantial yield benefit. So what do we do from here? How does this change things? What do we do different? We have some other things going on in this field that I'll talk more about here, fertility, that might lead to some stronger decisions. So fertilizer being applied, are you going to be that go-to resource to maximize that fertilizer investment? I think we probably should. But are you willing to utilize yield and other data layers to meet the 4R requirements to minimize environmental impact while at the same time maximizing return on investment? I think there's strong reasons why. Let's take a look at this field again. As you can see, we went out in the middle of that sidedress ammonia block and decided to take a look at also some different applications of sulfur products. So in the brighter green and red area, that was just straight DAP applied to the field. In the darker red area, we applied a sulfur-based and phosphorus product with nitrogen supplemented to that. We put check strips out in the middle. We also laid some micronutrient trials. The darker green and the darker blue, and you see that's where we put on some micronutrients just to get just to see what would happen. Was there even another impact where we already had a sulfur product, adding another micronutrient application to that? I can tell you there's not any real definitive answers here yet, but there's clearly enough. We're going to take a look at it and explore it and see if we can understand the return on investment of applying sulfur, at least to our cornfields. We're also looked at them on soybeans. I'm not going to go through that today, but we're beginning to really trying to understand what is the value of these micronutrients, specifically of sulfur and other products, and when do we apply it? What's the right time? When does it happen? Is it fall applied? Is it spring applied? Is it in season? Those are the kind of things we're trying to look at to maximize that return on investment of my fertilizer dollar. Ready or not, here it comes. Prepay season's near. And are you going to partner with your grower to develop a plan for the coming season? Or are we just going to generate another Excel document or PDF form? I'm going to make the case for software tools that allow you to streamline that process so you can do more than just collect a check in December. Because let's be realistic, if we look at some of the input prices for things like DAP, potash, some of these other crop nutrition products, even nitrogen, there's some pretty favorable prices right now, coupled with some really favorable commodity prices. And when we begin to stack that together with a complete plan of what we're going to do throughout that season to maximize ROI, there's some really strong reasons to be locking in both sides of that equation right now. And are you utilizing those tools? Are you partnering with your growers to have that discussion? So this is a bit post-mortem here. I'll tell you that straight up. This is just a business performance of how this cornfield was responded and what was our overall profit from this. You know, we did all right thanks to the commodity movement, thanks to Mother Nature. A lot of things went right. And, you know, we made some good money on this field. But now as we go and break that down and begin to look at 2021 and how changes we can make, we can begin to break down what all those individual costs were and how much that not cost necessarily for a ton of fertilizer or a gallon of product or a bag of seed, but what was that impact to the commodity price? What is going to be my break-even price for growing corn in 2021? I'm going to tell you as we continue on, you're going to see there's some really strong reasons why we need to be making some marketing decisions right now for some, you know, fall delivery of corn and soybeans for 2021, especially if I lock in the front side and some of these input prices right now. There's plenty of ways and plenty of reasons why I ought to do that to lock in some profit, at least on a few acres at this point. Once these plans are put together, you have a complete list of what needs to be applied. So this is a shopping list of products I need for 2021 if I was going to plant this field back to corn again, or my farm back to corn again. As you can see, there's $61,000 I need to spend on crop protection. I haven't included fertility here. I haven't developed my fertilizer recs for 2021, but fertility could be in this shopping list as well. Maybe all those prepaid dollars today just need to be committed right to plant food. Some cases that's probably going to be the best choice, but this gives you that list of products we need, whether it's to do prepay, whether it's to help you as a retailer and a service provider to having those products available. You're going to know if you're working with me what products I need and probably roughly about when I'm going to need it based upon when I plant a crop. The last important piece out of this whole analysis and developing plans and putting together a plan with the grower right now is this business performance. You know, with an average yield of 53 bushel and an average corn yield of 164 and wheat of 76, you can see my break-even commodity prices are 704 and 388 for soybeans and corn. You know, right now, there's a lot of reasons why I need to be doing that. We can lock in those kind of prices or better. Soybeans, we can lock in that better right now. Corn, we're getting really close to probably we can lock that in for some fall delivery corn. And there's an opportunity there to have a different discussion that's not centered around how many ton of fertilizer you're going to need to buy, how many gallon of crop protection. It really comes back to what I said before. It's more of a whole agronomy operations platform that we operate in, that as these plans and these recommendations can roll into work orders, that then can roll into your billing systems and really streamline that whole process from the time what started as just a prepay and not just taking a check has now rolled into a solution that can get all the way through the application of that product. At EFC Systems, we are improving profitability through data-driven outcomes. We're working for the farmer through the ag retailer or service provider like yourself to help him improve his profitability, because the more he's profitable, he's likely to be there as a customer for you. Our promise to you is our vision to meet the demands of today while developing tools for the future. And that we develop processes that will streamline and help you make better decisions. We're committed to you, and we're looking for a commitment from folks like you who want to be strategic partners with us to help develop the next set of tools and the next set of processes needed to streamline that, to make you more efficient, to help improve the profitability of the grower. Our competency is deep. We have people that's worked ag retail. We've got a number of software developers. We even got farmers on staff to help us do the best we can to develop the tools that you need to deliver to your grower to be successful. Because empowering agribusiness professionals and farmers with information to succeed is the core of what we promise and what we're focused on. Throughout the year, I've talked about elevating the farm gate conversation. You know, a year ago, it was how do we change that conversation? But now it's more how do we elevate it to a different level, have a different discussion, and how do we work with that grower to be a partner to improve his ROI and improve his profitability. If you'd like to join me in this process, feel free to email me. My email is on the screen. My next slide also has my phone number. Feel free to reach out at any time. I'd be happy to visit with you and talk about ways that we can work with you to help you elevate your conversation with your growers. Once again, it's been our privilege to sponsor this entire series. I'd like to thank all of our speakers who's joined us throughout the summer and fall, and thank you for listening.
Oh, thank you, Jeremy. Are there any questions? I think we have a moment or two for a question. Well, Jeremy, do you have any comments based upon the speaker, Eric, to add? Or
No, it was much like yourself. It was a great presentation, and I enjoy listening to Eric anytime we get a chance. And ultimately, my presentation centered around return on investment, and Mother Nature plays a big role in that. And it's kind of intriguing watching the trends. And as you talked about, Eric, what happened over the summer, I mean, that was straight up what we saw happen. And we were in a spot, we were pretty fortunate and caught some of those fall rains. Now we missed some of them when we needed them there in July, but there's so many things we can't control, and that's why I'm so passionate about whether I'm talking about fertility or whether we're talking about seed selection or whatever the choices, the things I can control. I just got to use all the data and everything I've got available to make the best choice I can make, because like Eric says, we can't control the weather, and we're pretty rough forecasting it more than 45 days in advance. So I got to stack the deck in my favor as much as possible. And utilizing tools that are on the market today, I think, is critical to increase your odds.
I think it's very important to understand the source of that information, how it can be applied, because every information, Eric, as you mentioned, may have a little facet that's sliding it one way or the other to pique interest or to develop clicks or added clicks. And so knowing that background and knowing some of the underlying information should be really taken into place. And I always recommend producers and consultants to dig into their data sources, dig into the information base, because you don't really know what's done on the background sometimes. All right. With that, I'm going to say thank you to Jeremy. Thank you to Eric. I think we got a little bit of internet lag with Eric, but CCAs, remember, the QR code is right there in front of us. So you need to scan it, get your CCA app that you signed into, use your camera pointed at the screen. Of course, remember, if you have any troubles, let Sally know. Her email's been listed in the chat, so you can copy and link that. Last couple seconds, I just want to say thank you again to Eric. Thank you to our sponsors, EFC Systems. And remember, keep in mind, join us December 15th through 17th for the virtual InfoAg. Registration will be found at infoag.org. That's where you see the full list of speakers that was going to be at the Real in Live Person InfoAg. I know myself, I'm really excited about seeing everything that's on there and getting to virtually to interact with the folks that I get to interact with every July. Appreciate your time. Appreciate the efforts. Appreciate TFI. Appreciate EFC and Eric. Thank you guys very much.
Thank you, Brian.
Thanks again for joining us today and for our sponsors' support. Please visit infoag.org for more information about our webinar series lineup and to register for InfoAg Live in December.